Everyone, welcome back to Calculus 1. We are talking about the slope of a tangent. And then we say that the slope of tangent, it is a limit. It is a limit. And basically, there are two equivalent formulas. It could be written into this fashion or the other fashion. They are really the same. Or they are equivalent. They are the same. Okay, they are the same. And also, indeed, as I'm saying, you really want to know, so far, the slope of tangent, really, it is the derivative. It is a derivative. How about let's take a look, one more example. And this example, it is also from the textbook, mostly, if all possible. I just take the example from the textbook. This is checkpoint 3.1. We want to find out the slope of tangent line to this squaring function at x equals 4. Square root of x, okay. The slope of the tangent. And the slope of the tangent, it is such a limit, okay. And then I did my calculation, and the only thing I want to point out here is to find our limit, we plug in value, the so-called direct substitution. But anyway, you may want to know, it is always the case when you consider the slope of tangent or the derivative from definition, you cannot always to find out derivative using the direct substitution. They always require actual work. So this time, what I realized here is we are having square roots. And remember, to handle the situation with square roots, one possible way is to consider the radical conjugate. So the numerator part, it has a radical conjugate, right? Square root of x plus square root of 4. But to keep this fraction balanced, we do the same for the numerator and the denominator. There is the same conjugate on the denominator. Still, you don't want to cancel them. What I did, you multiply numerator out. Remember, the product of the conjugate pair, or really this is the product of difference and the sum, it turns out to be difference of squares. So square root of x squared, it is just x. Square root of 4 squared, it is just 4. So the numerator tends to be x minus 4. And then, don't forget that we do have the denominator, right? But interesting enough, we just got the same thing again from the denominator, x minus 4 on the top and the bottom. So it's cancelled. So the limit we need to consider, it is just 1 over square root of x plus 4. And we repeated it many times. To find out the limit, we do consider direct substitution. And the reason it's not done in the beginning, it is not possible. And now you get to the limit in a new fashion. Give a try for the direct substitution. It works perfectly fine. Replace x with 4. Square root of 4 plus square root of 4. Square root of 4, that's 2. 2 plus 2. They're both in the denominator. So that's 1/4. That's 1/4. Square root of 4 plus square root of 4, that's 4. And besides, it's in the denominator, so that's 1/4. The slope of the tangent line to this square root function at x equals 4, that's 1/4. That's 1/4. Okay. So I think we did 3 examples about the calculation of the slope of tangent using limit. And indeed, that kind of calculation for the limit, it has more application than the slope. Okay, so we simply call that kind of limit. The limit, it is the limit of difference quotient as derivative. Certainly one way to explain derivative, it is the slope of the tangent. And also, I want you to know this quotient, difference quotient, really it is the rate of change, right? Slope, it is the rate of change. Because of limit, and really we can consider this is the limit of the rate of change at that particular point A. So it is called as the instantaneous rate of change. So I'm saying at least you want to know there are two ways to explain derivative. Derivative, it is the slope of the tangent line. Derivative really reflects the instantaneous rate of change. And also, speaking of instantaneous rate of change, I hope, well, I suppose we all have the driving experience, right? When you drive, if you keep a close eye on the speedometer, and you see mostly at every moment, the speedometer will give you a different number. That means at a different moment, there is a different speed. That is the instantaneous speed, or precisely the instantaneous rate of change. Instantaneous rate of change. Okay, so that is the derivative. Derivative really it is the slope of tangent, or more precisely, it is the instantaneous rate of change. And there are two formulas. They are equivalent. Again, they are equivalent. I think for my other examples, mostly I use this first formula. And for the next example, I'm going to use this alternative or equivalent formula, okay? Because when we move to our next section, when we consider derivative as functions, and it is really easy to use this formula. So for now, the example I'm talking about, it is 3.6. Still, I'm in section 3.1, okay, section 3.1. The function, it is a quadratic function. A quadratic function, we want to find out f prime of 2. F prime, it is for the derivative. F prime, or really the derivative, it is the slope of tangent. So I copy and paste the formula. I'm using the equivalent form, okay. So, and then I plug in the formula, plug in the number. First of all, a is 2. Okay, f of 2 plus h minus f of 2. And then I plug in 2 plus h into this formula, replace each x with 2 plus h. And also similarly, I replace each x with 2 here into the same formula. Then do a subtraction. And then you want to expand this entire thing. If you are watching the video, if you have a hard time to track all the terms, you want to pause a little bit, or you can start from notes to see if I got all the terms correctly. So this is the square of sum. We got 3 terms, and you multiply this out, and multiply that part out, and I got a lot of terms cancelled. Eventually, I think for the numerator part, I have 3 terms left, 12h plus 3h squared minus 4h. And also 12h minus 4h, that's 8h, right? And then we can factor out h from the numerator. H is a common factor from numerator. And also we do have a single h in the denominator, which means h is cancelled. And using this alternate equivalent formula for the derivative, it is always the case, denominator 0. But after doing the manipulation I did here, I figured out h is cancelled, right? There's h on the top and h at the bottom. So the limit we are looking for, simply it is 8 plus 3h. And again, direct substitution, really, that's the only reliable way to find our limit. And now it works perfectly fine. Replace h with 0, and then we got the limit as 8. F prime of 2. F prime of 2 can be considered as the slope of the tangent line to this graph at x equal 2. And indeed, we just figured out this number is 8. This number is 8. This is the material in section 3.1, the definition of a derivative. Thank you for watching. In our next part, we will expand the definition of derivative as a function. Derivative itself, it is a function. Thank you for watching. See you next time.